Hi friends, welcome back to Dutta Engineer's Choice. Hope you all are doing absolutely fine. My name is Somarup Datto. Today we learn in one of the most and basic toolpath in Powermill, that 2D curve area clearance and 2D curve profile. So here you can see that curve is we are selected and we are just do programming in this curve accordingly. So how to create it, how to create 2D curve area clearance, and what are the major settings to in this toolpath we are discussing at the step-by-step process. So here you can see the simulation is started. Okay, before start the video, just subscribe my channel, like and share to others, and don't forget to hit the bell icon. It will help to finding my playlist in Powermill. And previously we are discussing some of the toolpath in Powermill. If you check it, just go through my description below and check the video link. So friends, just start it. So friends, at first we close all these things because we will starting point in beginning level. So we will just open AutoCAD. So why AutoCAD friends? Because we need a 2D curve or 2D drawing. So friends, you will see the AutoCAD user interface is open. So I already set up in my units. So if you first time open in AutoCAD, so please set up in units, and I will just type REC. So here this finding REC is rectangle. So I'll just click on REC, and also you can find the menu bar in rectangle command. So I'm just select specific point and 120 my rectangle area and OK. So my rectangle is created. Then friends, we are just type CL. It's mean center line. It is a shortcut key of center line. We are just selected and select the specific two line, and my shortcut, my center line were created, and we just need a curve profile. So I will create one hexagonal profile. So just select line, L enter, and select the specific point, select another specific point, and just take the midpoint and enter, and just escape. And again I will select line command, L enter, select the specific point and select midpoint, just select enter and enter. Okay, so we are just using mirror command to the another surface. So mi enter, mirror, select the all three lines and mirror about to this line. So how will be selected friends? Just escape and select this line, mirror, mi enter, select the three line and select this line, and it will be rotated. We will create it. Okay, and enter. So our mirror is created. So this is the simple profile friends we are created, and we will create up to program in this curve profile. So if you don't have any model, it doesn't mean Powermill don't create in program. Powermill create and helps the single curve or multiple curve programming. So but we just save in this file in DXF format. So how do we save it? We just make it file and save as. Here we will save in desktop. Okay, and save in this, it is drawing format, but we are now required DXF and my curve profile. Okay friends, and just save it. So where it is saved? It is saved in my desktop. So this one is my the curve profile DXF format. Now we just simply open Powermill. So in Powermill, we will select the curve in Powermill. So how to be selected in curve in Powermill? In our previous lecture, you all are know that the model we import in Powermill, but today we are taking in a single curve in Powermill. So we just simply file, import models, and where it is located? It is located in desktop, and desktop the my curve profile and open. So friends, please carefully notice when it's open it doesn't show, because in Powermill it is opening out here. We will take some patience for that opening and importing in Powermill to any models, any others platform. Okay, now it is open, but if you clearly show that it will be not showcasing here, it's not we are seen here, so we just need wireframe on. So now we are not seeing here, so we just suppose it here. So this is the our curve profile. This is our curve profile. Okay, we missed out to delete the center line. Okay friends, so if you get one more chance, we just delete the center line or erase it, re-enter and save it once more. Save as in 2. Okay, save it. It will just minimize it and just close the Powermill. We didn't import here also, we just reopen Powermill, because if we import here it will already created a curve, it will take look up to in this curve. So it's better to we will just close it and reopen the Powermill and import it. Okay friends, so we just import model and desktop and 2, open. It will be opening friends. Close, select. It will import it friends. Okay, so here first we need 2D, the toolpath what we are using in this lecture, that is 2D curve area clearance. Here the show how to be the toolpath is going through, and this is 2D curve profile. Here is the make it a symbol or make it a okay. So at first we will need one pattern, because it's accordingly programmed in the pattern. So what we will do this, we will just select pattern and right click create pattern. So again we will select this one number is pattern and curve editor. Curve editor, choose we composite curve. Composite curve, we will select this one curve and it will already selected in this total curve, and we will accept it, again accept. Okay, rest of the things and make we will need to be block, just required block, and we just select the curve and calculate it. So here you are all seeing our block is calculated in this curve, that's why we need in the rectangle 2D curve profile. Okay, but we make the thickness of this curve. Okay, so we will just minimum Z limits, we will make minus 25, enter, and it will be locked and then calculated. So our model stock height and thickness we will given, accept it. So friends, hope we will get understood how we will create the single curve or multiple curve programming, or we are not, this is not the model, this is just curve and we will make it the block. Then we will create work plane and we will make preferable to work plane position using block and select the at a point, then make it the work plane editor. Work plane editor, this is perfect, we will not moving any changes, accept and just make it activated. So here when we activate it, our block is disturbing, our block is not showing, so we are just recalculated our block and it will be showing accordingly and accept. Okay, then friends, we need one pattern and we need one work plane. Then we are just go in toolpath. Toolpath, curve machining, 2D curve area clearance. We are all talking about 2D curve area clearance in this tutorial. So how to be created? Now you are seeing that how to be created in 2D curve profile. Okay, so this is the settings and toolpath menu. So we are choosing work plane and block, then we are choosing the tool. So we selected end mill cutter, and in the tool diameter is we selected 6. Okay, and also we are, if required, we are selected in holder profile. Okay, accept, and the end mill we will select the specific name that our operator will easily understand the programming and tools, that what tool we are using in programming. So I select end mill 6. This is the 6 is the diameter of tool. So this is just a training purpose, we will select it, and then we will machine tool not required, limit we will not disturb, curve area clearance. Here you are the seeing the main important things. So first we will the curve definition. So we are selected here, not selected any curve. If you show here the pattern, if you uncheck, then here not selected any curve. So we are just selected a curve, and if we are selected a curve here with the green lines we are just showing. So what is this actually? So we are just here one option, enter activity modify machinable section. Modify machinable section we are just open it. So what is the purpose modify machinable section? Because friends, it is just a purpose of machinable area what you are machining in this toolpath. So we are just allocate of the power mill and recognize it that the specific area. So if we select the tool, it will get outside. If we select again the tool, it will get inside. So it is our requirement that which area we are need to cut and we are need to the programming. Okay, so we specified the inside area and accept. Then the lower limit, it means the what is the limit we are consider in the toolpath. So we are considering it is 15 mm. So we are just selected 15, enter. Then the style, if you are style in raster, I will show you step by step what is the difference in raster, offset and vertex. So we are just selected raster. Cut direction we are selected climb. Curve thickness means what thickness we need to allow for the our finishing toolpath. What is thickness we need to allow? So we allow 1 mm thickness. This is the curve thickness. Step over we need to create that 10 mm. 6 tool we need to create 8 mm. Okay, it is the appropriate in 6 mm diameter tool. So we are just making video in training purpose. So it's if the again the another option, cut distance. Here we are vertical extend distance. There are 3 options: stock depth, limit and number of cards. So here if you selected stock depth, so what is the stock depth of our model? So we are just consider 15 mm. We are raised down in along Z in 15 mm. Okay, then the horizontal step over. Horizontal step over, if you selected 15 mm, here also you are selected 15 mm. Okay, then we just need to be once calculated. So here if you selected calculated, here the toolpath is ups and ups arrow. So this is not the correct. So here we selected curve area clearance lower limit. If you selected minus 15 mm and then the calculated, so here you will see our toolpath is minus direction along the Z. So this is the mistake we are made in lower limit, that the plus 15 mm. Its corrective is it is the lower limit and it will also always be in minus. Okay, so here we are just showing that the raster profile, the straight profile we are just created. So we just need some changes here. Here we selected offset profile and cut direction we selected any. Okay, and step over we need to be selected 8 mm calculated. Okay, so here you are show our toolpath is calculated. Okay, the rest of other option we also need to apply for that we selected cut distance. So friends, here the cut distance, so the vertical extend distance, there are three options, is the limit, stock depth and number of cut. So stock depth we really mention it, so we are consider the 10 mm stock depth, and step down the 1 mm, it's okay for that. And the horizontal step over, so here we also selected horizontal step over 10 mm. So I will show that friends, what is the, if you selected the horizontal step over, then our curve area clearance, it will automatically step over selected that 10 mm step over. And lower limit, if you selected minus 50 mm, we will change it, that is minus 10 mm, because our that should be minus 10 mm, because our cut distance we are consider stock depth in 10 mm. And finishing friends, we are floor finishing, we attach our floor finishing in final step down, and here we will consider 0.5 to our final step down. And friends, here the option in draft. So what is the purpose of draft? So the draft basically function to the angle. So our tool to the in this profile, it will be create some angle, and the wall it will be create some angles face. So we just considering the draft angle, and we will select it 2 mm to the draft angle, and then friends we are just calculated. So here you can see what is our toolpath is ready. So this is our toolpath. If you have any doubt in this toolpath, just comment and in the mention your name to this comment, and what the doubt section you just face in, I will describe you, I will fully explain you. And we just here friends, our toolpath is ready. Here the right side, it is the safety status in our toolpath, and we just settings and made a name. This is now showing the toolpath name is 1. So we will select it 2D roughing. So we just close and 2D roughing toolpath. So friends, we just simulate it. So here I will show the simulation, and the mode is fixed direction. Okay, play. So friends, you are just showing that our toolpath is simulated and it is running. And here I am just before telling that there is draft angle, so here you are just saying that our tool path in the 2-degree draft angle and the 1 mm curve thickness in this wall. You are clearly visible, friends. This 1 mm in these steps we are removed in our finishing tutorial. So I just exit it, and this one is our 2D curve profile toolpath, friends. I hope you understood. Now we are curve area clearance. Okay, so now in this toolpath we are back to home, and we will select it 2D curve profile. In the same curve we will select it 2D curve profile. We will just make a tool and the little smaller tool, and we will select it end mill and make it 4 mm. Okay, and this is the name. We will select it END4, the 4 diameter tool, and we will just select it curve profile. It is already selected, friends, the curve profile, and just position. This position we will select in this. It is the right approach. If is selected in this, it is not the right approach. So position selected carefully, and the curve thickness, we are made the curve profile in finishing toolpath, so we don't need any curve thickness. Okay, friends, cut direction claim, I just simply calculated, and here you are showing that our toolpath is calculated. I don't check any other option. So if I am check the stock depth will be 10 mm, and the step down we are considering 1 mm. Okay, and the horizontal stock depth. Okay, and stock width, if you selected stock with any kind of width you are given, so you are just selected here. Otherwise you don't select it and just simply get it finishing. We don't need it the floor finishing, and draft, and we don't need the draft. Or if you selected the draft, you just selected that 1 mm. Okay, and just calculate it. So it will be calculated, friends, and our finishing toolpath is ready. So if the changing in this toolpath name, we will just select it in 2D finishing. We will just mention it 2D. Okay, and just close it, and we are just simulated, friends. So in the simple same one curve, we will select a 2 program, and we will run here the 2 program. So you are just showing how will be created in 2D curve profile. This is the most important one toolpath in Powermill, friends. If you don't have any model, it doesn't mean you don't make programming in Powermill. Powermill have the good single curve profile and the very commonly uses toolpath. So now I am showing the G code on this toolpath. Okay, so firstly I am just showing block, and here in this toolpath section I created 2 toolpaths. The first one is 2D roughing and the second one is 2D finishing. So I just selected 2D roughing, and I am just press right click, and here one option found that create individual NC program. So I am just selected, and here in the Explorer view the NC program is the one option over there. I am just open plus sign and the 2D roughing NC program. Here I am just selected, and again right click, and here one option is settings. So firstly I am open in settings, that is where is my output file, NC program file is saved or located. So here output file is the area of my NC program, and here if you select it, here the machine option file, this is the controller basis. So I am just edited, and here option that Autodesk Powermill already given these type of controller like Fanuc, Has and Siemens. So I am just simply select Fanuc and accept it, and here the machine output file is Fanuc. Okay, rest of the others option you just, if you want it then you just check it, that NMIL 6 and the all those things. Coolant level is standard, and I'm just write is the here the option is the write. I'm just write. So if I am writing, the programming will save automatically the NC file or the tab file. So in the same process, I am again choosing 2D finishing, and again I am choosing the create individual NC program, and the 2D finishing I am just write it. So the two numbers of program NC program are created. So where it is saved, I am just open it, friends. I am just again choose file. So this one is my NC programming file. In this where I am saving the 2D car profile Powermill file, in this area, the NC programming one folder is opening, and here the two programming, this is called tab file. This is called the tab file. This is one is 2D roughing. So here you just see the 001 O is the donated in Fanuc controller in every system. So this is the programming number, and this is the programming name is 2D roughing, and programming date where I am created is the already showing, and this is the our total program. Here is the G code you are finding. It is the M06 and is 15,000. I am not changing the feed and RPM. If I am changing that it will be showing here. Okay, it will show here, and the S is spindle speed, and the feed and RPM, all those things here already showing. In the same process, the next program is 2D finishing. 2D finishing, here we just need to show the 2D finishing program. So if it is clear, you will just show how the 2D car profile programming is created and how the NC program is working. So if you running in the machine, you just need to select this 2 NC program and to the your memory card or the pen drive, and just import your machine. Okay, is this the copy and paste? And I hope it will be all are clear. So thanks for the watching.